Hello, students. This is Dr. B, and we're going to run through the Concord Consortium Plate Tectonics module, the first two activities, which will be our lab today. We'll probably just get through the first one in this video, and I'll have additional videos to help you through the rest of them. Once you've signed in to learn.concord.com, you can hit Run by Myself. And you should come up into what will the Earth look like in 500 million years? That's the question we're trying to answer today, or answer throughout this module, which has 5 activities. We'll just be doing the first one right now. We're starting with the Andes Mountains. The Andes Mountains forms the longest continental mountain range in the world. We know from GPS data that a piece of Earth's surface under the Pacific Ocean off the west coast of South America is moving towards the piece of Earth's surface where South America is found. This is also where the Andes Mountains have formed. So we've got an ocean plate moving one way and a continental plate riding up over that ocean plate, and there's some mountains forming as that continental plate rubs up against that ocean plate with a little bit of friction and starts kind of jamming up and piling up, kind of like you'd crumple a piece of paper. To understand what happens when two pieces of Earth's surface are moving towards each other that might form mountains, we're going to investigate this place in detail. To begin our investigation, we'll look at the geographic profile that gives us information about the elevation of the land along a profile line we'll choose in an area we're going to investigate. That's from P1 to P2 in this particular case. The graph's y-axis right here shows the elevation above and below sea level. If you're below sea level, it's minus, just like if you're below 0 temperature, that's very cold. Sea level is at 0, so negative numbers represent places underwater or below sea level. Positive numbers represent places that are above water, above sea level. Right now, unless you're scuba diving, you have a positive number on this sort of geographic profile. The graph's x-axis shows distances in kilometers between P1 and P2 on the map above. So here's P1, here's P2, there's the x-axis, and you can see the distance in kilometers. At what point on the geographic profile does the land elevation rise above sea level? So let's look. The water ends right here, and then we run into land right there. And if we look down, we can see it's about right there. And we know, we count the blocks between 700 and 800. 1, 2, 3, 4, 5. There's 5 blocks out of 100. So each of those blocks is 20. And I'll let you figure out exactly where this point is. How far from point P1 is the lowest point on the geographic profile of the Andes? So we know that all these numbers here are below the water, so the lowest point is going to be below sea level. And if we look here, this looks like the deepest part of the ocean, or the lowest part of the profile. And you can see on the x-axis where that is right here. On the geographic profile, look at the 670 mark on the x-axis. What feature might be represented by this elevation change? So it looks like there's sort of a chunk here, and then there's this trench here at 670, and then there's this other chunk here. So if we think about plates running into each other, and one plate subducting or diving underneath the other plate, this perhaps right here could be representative of that subduction, one plate going underneath the other one. To better understand the movement where these two pieces meet, we're going to look at data about earthquakes and volcanoes. You'll use Seismic Explorer, that's this map right here, and you'll see that a bunch during this module here. It's called a relief map because you can see it kind of looks 3D. The brown parts are mountains, so these are the Himalayas, these are the Andes Mountains. If you look here, these are the Rocky Mountains in North America. Green is kind of the lower places. You can see some rivers here in South America. The kind of beige is where it's kind of like medium tall. There's medium elevation. First, we're going to use data type to show the earthquakes and volcanoes that have happened in the Andes. To show earthquakes, check the earthquakes box and press the start button. So you go to data type, you press earthquakes, then you can make this go away, press start, and we can gradually see all the earthquakes fill in. Now the earthquakes are showing up in different colors because they're earthquakes at different depths. And I'll show you the key in just a minute. We'll let everything fill in so we get an idea. Now look where all along the Andes here, there's a whole bunch of earthquakes going on here. And also along this coast here. Think about what that might represent. The depth of the earthquake is represented by color. So the shallow ones are red and the deeper ones go all the way down to dark blue, and orange, yellow, and green are somewhere in between. The magnitude of the earthquake, or how severe the shaking is represented by the size of the dot. So these big dots here are very severe earthquakes. The little dots are shallower. Generally, the red ones are shallower and the magnitude is a little bit lower. Use the information you collected from the Geographic Profile to examine the relief map in Seismic Explorer. In this relief map in the Seismic Explorer, what color represents the lowest point of the ocean? Well, let's look. There's no key for this, but we can just look at the ocean and we can see that some of the deepest parts of the ocean are this really dark blue. So I would assume the dark blue is the deepest parts of the ocean. The middle part here running along the mid-Atlantic is called the Mid-Atlantic Ridge, and it's kind of like a little mini mountain range under the ocean. And if we take off all the earthquakes, you can see that mid-ocean ridge is a little bit lighter blue, meaning it's a little bit taller. The water isn't quite as deep. So let's take a snapshot of Seismic Explorer. I'm going to zoom in on South America here a little bit. Because eventually we're going to have to label the trench that we see in the Geographic Profile and the mountains. So I'm going to just take the snapshot here. And remember, the trench was really close to the mountains. And the mountains are brown, dark brown. That represents the tallest mountains. And if you remember from the Geographic Profile, there was a trench right next to the mountains. So I'm going to let you label the trench and the mountains. And you can do so by clicking, grabbing a pen tool right here. You can label what that is. And we'll grab another color here. And you can label what that is. Don't just put arrows. I'm putting arrows to just help you out a little bit, but you need to write what those things are. Now you'll investigate volcanoes. In Seismic Explorer, click Data Type and select Volcanoes. This will add triangles that show the locations of volcanoes on the map. So let's look at the pattern of volcanoes in the Andes. That's the mountain range on the east coast of South America. So I'm going to pull up Data Type here. I'm going to click off earthquakes just so we have less to look at. I'm going to look at volcanic eruptions, all of them. I'm going to fill in the more recent ones by pressing Start. And where do you notice these volcanic eruptions are taking place? I've been in the Andes. I've been in towns in Ecuador that actually have little signs like exploding volcanoes and which way to go to evacuate the town. So describe the pattern of volcanoes in the Andes. The Andes Mountains run down the east coast of South America. And where are those volcanoes? Where is that plate crumpling up and making mountains? And what do volcanoes tell us about what's happening to the tectonic plates? Think about that. Based on Seismic Explorer, how deep are the earthquakes that have occurred in the Andes? Well, let's go back to putting earthquakes on the map here. Oops, that's not what I wanted. Just gonna put earthquakes on. And it looks like there's pretty much every color of earthquake here in the Andes. And if we look at our key here, they go from 0 to all the way down to 500 kilometers below the surface of the Earth. So it looks like we have quite a range of earthquakes. I'll let you put in your answer and check it there. To understand what's happening, we need to look beneath the surface of the Earth. To do this, you can make a cross-section in Seismic Explorer to see the pattern of earthquakes underneath the Andes Mountains. Watch the video to learn how to make a cross-section. I'm going to play this video. You cannot do this on your iPad, unfortunately. If you're working on a laptop, you can do it. I have provided a couple of cross sections and I'll show you, I'll make cross sections in this video so you can look at them and you can take screenshots if you need to.
Seismic Explorer is zoomed in to show New Zealand. Australia is on the left. There are many earthquakes in this area. You can make a cross-section to see the pattern that the earthquakes form beneath the surface. First, click the Draw Cross-Section button. Then draw cross-section.
Australia is on the left.
To the line of earthquakes. When you have placed the line in the place you want it, click the Open 3D View button.
You can make a cross-section.
The cross-section shows a sloping pattern to the earthquakes. You can rotate the cross-section to see the view from the top and from the sides.
Then draw cross-section line.
When you are done looking at the cross-section, click the Close 3D View button.
Click the Open 3D View button.
The cross-section line perpendicular to the line of earthquakes.
Sloping pattern to the earthquakes.
Because when you draw the cross-section line parallel to the line of earthquakes, you don't see a pattern in the earthquakes.
When you are done looking at the
So always draw your cross-sections perpendicular to the line of earthquakes.
Why do we draw the cross-section line perpendicular to the line of earthquakes?
Okay, cool robot voice has explained what to do. So,
you don't see a pattern in the earthquakes. So always draw your
when you draw your cross-section, try to make it in the same place as the profile line so that you know you're looking at the same part of Earth's surface. Take a snapshot of your cross-section. On the snapshot, draw a picture of what you think the pieces of Earth are doing as they come together beneath the surface. So let's go up here. Oops. So I'm going to pull this down a little bit. I want to take a cross section about right here. So let's kind of find where there's like every single color of earthquakes. Pull our cross section across, perpendicular, and open the 3D view. Wow, look at that. There's a bunch of earthquakes really deep in there. So I'm gonna go down here. I'm gonna take a snapshot. On the snapshot, draw a picture of what you think the pieces of the earth are doing as they come together below the surface. Well, I'm going to draw the, I'll choose green for the ocean plate. I think the ocean plate is subducting and kind of diving beneath the continental plate here. So this is the ocean plate. And then over here, I'll draw the continental plate in purple, just because it's different from all the earthquake. So the continental plate is riding up over the ocean plate. I'm just going to put CON for continental. And so these two plates, there's actually, you know, there's not that space between them. I just left that there to make it clear that the ocean plate is diving underneath the continental plate, and that plate diving into one crust, diving into the other, there's going to be a lot of friction. It's like sandpaper rubbing on sandpaper. That crust isn't just going to want to dive into the ocean. Or dive into the ocean crust isn't going to want to just dive into the continental crust. There's going to be a lot of friction, and very deep friction, and that's what's going to cause these very deep earthquakes. So ocean plate dives, subducts. That just means it goes under the continental plate. Causing very deep earthquakes because of the friction of tectonic plates rubbing together. Anytime you have huge chunks of earth rubbing up against each other, you're going to get a lot of friction. And so there's going to be earthquakes, there's going to be other tectonic activity. There's probably going to be some lava involved trying to escape, magma, which will become lava when it hits the surface. Explain what you think is happening with these two pieces of Earth's surface to create the pattern of earthquakes. Well, I kind of explained that to you and what the two plates are doing, so I hope that you can construct an answer to number 9 that makes sense to you. Question 10. What might you look for in another place on Earth to know if the surface pieces are moving towards each other? Well, one landform that we've seen here in South America, when we look, let's close this 3D view, and I'm going to peel off all the earthquakes. We can see mountains right here. And when one piece of crust hits another and crumples up, it makes mountains. My fist here is representing the mountains here. And so when the plates converge, when they come together, come together, we see mountains. That's the landform that we see. So mountains means a plate is crumpling and it's running into another plate. Trenches are an important piece of evidence to help us explore where pieces of Earth are moving towards each other. In the picture, the Andes Mountains, the trench is shown as the darkest blue on the map. So if we pull the map up here a little bit, we can see this is very, very dark blue. And that very, very dark blue here, right on the edge of the continent, is represented in this profile map as this trench here. The mountains here, the Andes, which are shown in like kind of dark gray here on this relief map, are right here in this profile. Ocean trenches are long, narrow depressions in the seafloor. These oceanic features are the deepest parts of the ocean floor. In the profile, you can see the trenches are very deep and pointed. So a trench is deep and pointed. As you explore different parts of the world, look for this landform as a place where Earth's surface are moving towards each other. So when we have plates that are running into each other, converging, coming towards each other, we're going to see mountains and we're going to see trenches. The trenches is one plate subducting or going underneath the other one. The other continental plate is folding up and making mountains. So remind yourself by moving your hands in the same way, kind of crumpling up, making a mountain. This is convergent plates. They make mountains, and then they have this trench here because this plate is going under the other one. So let's find out how the Aleutian Islands formed. Another place where GPS data indicates two pieces of Earth's surface are moving towards each other is part of the state of Alaska. Just like in South America, there are mountains forming, but in this place, the mountains are mostly underwater and have created a chain of small islands that separate the Bering Sea to the north from the Pacific Ocean to the south. Let's investigate how this chain of islands formed and see what is the same and what is different from the Andes. What evidence would tell you if two pieces of Earth's surface are moving towards each other? Well, we just looked at this on the previous lesson. We saw that there was a trench where one plate is diving underneath the other, and we saw that there were mountains, and those mountains could be underwater. Just like with our investigation of the Andes, we'll start by looking at the geographic profile of the area, which provides clues about important land features along the chain of islands. Oh, that looks kind of like a trench. That looks kind of like mountains. What do you think? The graph's y-axis shows the elevation. Remember, minus is below sea level, plus is above sea level. So most of the activity here is happening below sea level. The graph's x-axis shows distance in kilometers between points 1 and points 2 on this map. So point 1 is point 1 here, and point 2 is point 2 here. At 530 kilometers, so 5, let's see, there's 5, so just 20, so right about there. Right about there. From point 1, the geographic profile shows an island above the water. So this is the first place that this mountain range gets above water. Based on the geographic profile, how tall is the island from the seafloor on the right side? So here's 0. And we know from 2,000 to 0 is 1, 2, 3, 4 chunks. So each chunk is worth 500. And this is about 1 chunk up. And so what do you think it is? Each chunk is worth 500. We know that because I took between 0 and 2,000 and was divided into 4 chunks. So I divided 2,000 into 4. I got 500. So I know each chunk right here on the y-axis is 500. You figure out how tall this part is. Now we know what the profile looks like. Whoa, sorry, I'm making myself dizzy. Now that we know what the profile looks like, we can use Seismic Explorer to investigate what earthquakes and volcanoes have happened here. Seismic Explorer is zoomed into a relief map of the Aleutian Islands. Let's zoom it in just a little bit more. Set the data type menu to show earthquakes and volcanoes. To show earthquakes, check the earthquakes box and press the start button. Use the relief map and the earthquake and volcano data to answer the questions below. So let's look and see. Make a prediction in your head what you think you're going to see along this line right here, along this mountain range that's underwater. That just makes a chain of islands. What's the pattern that you see with the earthquakes and the volcanoes, and how does it line up with that mountain range? What is it telling us about how these two plates, this plate up here and this plate here, are interacting with each other? Based on Seismic Explorer, are there volcanoes in the Aleutians? Well, let's look. We've got a key here. Well, active eruptions, all kinds of different triangles here showing when the volcano last erupted. And some of them are pretty active. So it looks like yes to me. There are lots of triangles here, which represents the volcanoes. Based on Seismic Explorer, how deep are the earthquakes that have occurred in the Aleutians? Well, it looks like we have some red, some yellow, some green. I'll do a quick cross section for you. So it looks like in this particular case, we're looking somewhere between 200 and 400 kilometers deep. We're not looking at quite as deep as we did with the Andes. Create a cross-section of the earthquakes that is in the same region as the geographic profile line shown. All right, I think I just did that, but let's just make sure here that yep, that's pretty much in the same place. Maybe I can widen it up a little bit here. Let's get it right where they want it. Okay, there we go. So create a cross section. If you want to take, you can put it in Notability. You can take a cross section of your screen right, or a screenshot of your screen right now, because in iPads you can't do this particular cross section. In the Tectonic Explorer, which is a little bit different, you can do the cross sections. Based on the earthquakes you see in the 3D cross section of the Aleutians, what do you think is happening with the two pieces of Earth's surface? Well, it looks to me like one plate's going down and the other plate is kind of riding up over. But you can draw your own conclusions. What would you look for in the geographic profile and in the earthquake and volcano data to know if the two pieces of Earth's surface are moving towards each other? Well, we know with convergent plates, we get a trench because one plate is subducting, and we get a mountain range. We also get lines of earthquakes and volcanoes right on the line between the plates, right about where the trench hits the mountain range. So, using a model to investigate Earth's surface. So far in this activity, you have used data to investigate two regions of the Earth where two pieces of Earth's surface are moving towards each other, the Andes Mountains and the Aleutian Islands, where there are underwater mountains. Now we'll use another tool geoscientists use, a computer model, to better understand what's happening as these pieces move. We'll do this part. We'll continue activity 2 in our next video. Thanks for watching.